Here we have a typical distance problem where we have two trains. The first train, a freight train, leaves the station at 1 o'clock or 1 p.m. in the afternoon. The second train, a passenger train, leaves at 5 p.m., both traveling at different rates. The rate of the freight train is 30 miles an hour, while the rate of the passenger train is 50 miles an hour. And we want to know, when do the trains meet? The key to this problem is the equation. Rate times time equals distance. So here's the key right here. Right here is the key to the problem. So what you want to do is set up a little grid, a little box, and set it up with the equation on the top. You have rate times time equals distance. And then what you want to do is set a row for each of the trains. You have the freight train, so let's do FT for freight train, which is traveling at 30 miles per hour. Departure time is 1 p.m., but you don't need that 1 p.m. You just have to kind of remember that. Let's call the departure time X. And then the passenger train travels at 50 miles per hour, so the PT or passenger train traveling at 50, and its time is going to be less than the amount that the freight train is traveling. Actually, with a difference between 5 and 1 is 4 hours. So we would have X, the time, minus 4 hours. And from this, we do the equation. Rate times time equals distance. So 30 times X is 30X. And 50 times X minus 4 for the passenger train is 50 times the quantity X minus 4. Now here's the key, that we have the equation, right? And the other thing is that the trains travel when they meet, okay? They both meet at a certain place or time. And this here is going to be equal in both cases. So there we have our equation. The equation for this particular problem will be found in the box that is related to distance. So 30X equals 50 times the quantity X minus 4. And that being the case, we will have to solve for X. That will give us the time of departure or not the time of departure, but the total time traveled by the freight train. And then we just add it in real time to its departure time. So let's look and see how we would do that. We have 30X equals 50 times X minus 4. We use the distributive property, 50 times X, so 50X minus 50 times 4, which is 200. That's equal to 30X. If we want to, the way I would do it is keeping everything positive, put plus 200 here and put minus 30 here. So minus 30 on both sides and plus 200 on both sides. When we add it together, we have 200 on the left, and we have 0 for 30X, minus 30X, and we have 20X here, 0 for 200 minus 200, plus and minus, they're inverses of each other. Then we're going to divide by 20 here and here, and we're going to get 10. So 10 equals X. And when we're doing that, what we will have is 10 hours, right? 10 hours of travel for the freight train? Well, the question was, what time did the freight train leave? The freight train left at 1 p.m. plus 10 more hours p.m. Okay, gives you 11 p.m. That's the time and the answer that we're looking for. So the key is rate times time equals distance. And that would be how you would solve a simple passenger train, freight train distance problem where the two trains are traveling and you want to know when it meets. If you like this video and you're interested in having some tutoring, feel free to contact me either by email or by my phone, which is 302-855-0615. Thank you so much and have a good day.